Education. Education, baby. Come on. Education has no end. Education.
Trends in chemical properties of period 3 elements. Welcome. Metals. Metals in period 3 are sodium, magnesium, and aluminium, and their reactivity decreases across the period due to decrease in atomic radius and increase in the nuclear charge, which increases the attraction between the outermost electrons and the nucleus. So what we are saying here is that the metals in period 3 are sodium, magnesium, and aluminium, and their reactivity decreases across the period. As we move across the period, there is an increase in the number of electrons to be lost, and also the atom becomes smaller as we move across the period. Therefore, the attraction between the nucleus and the outermost electrons is stronger in aluminium than in sodium. Therefore, sodium loses its outermost electron easily or requires less energy to lose its outermost electron. The number of electrons increases, hence more electrons require more energy to remove. Hence, sodium, having the largest atomic radius and loses only one electron to become stable, is the most reactive. That is what I had just explained earlier above. Aluminium has the least atomic radius and loses 3 electrons to become stable. Therefore, it is the least reactive. Silicon. Silicon is the 4th element as we move across period 3. It has 4 electrons in the outermost energy levels. Usually, silicon does not form ionic compounds because it will require a lot of energy to lose or gain 4 electrons. Therefore, it forms compounds through covalent bonding. So bear in mind that silicon can either gain 4 electrons or lose 4 electrons because it is at group 4. So it does not gain nor lose, but it forms compounds by sharing electrons. That is covalent bonding. Phosphorus, sulfur, and chlorine. Let us look at their reactivity. Now, chlorine is the most reactive among the 3, followed by phosphorus, then sulfur. The reason is because there is a decrease in the forces holding the molecules together. Therefore, chlorine, having relatively smaller atomic radius and requiring only to lose 1 electron to be stable, is the most reactive. Argon has a stable configuration and therefore does not react. So group 8 element, argon, we said they do not react because they are stable. They neither lose nor gain electrons at room temperature or at normal conditions. Now, reaction with oxygen. We want to see how group period 3 elements react with oxygen. Now, the metals, let's start with the metals. Sodium and magnesium react with oxygen to form their respective oxides. Now, this is chemistry that we learned earlier in the topic of chemical families. So refer to chemical families to see how sodium and magnesium react with oxygen. Aluminium, when heated in oxygen, it reacts to form aluminium oxide, which is unreactive. So once aluminium is heated in oxygen, it forms a coating around it of aluminium oxide, which prevents further reaction. This oxide layer prevents further reaction. That is what I had said earlier. That is why aluminium is used to make cooking vessels such as sufurias. So that reason makes it suitable for the manufacture or making vessels for cooking. The equation for the reaction is aluminium plus oxygen to form aluminium oxide, which is a solid. Now let's look at reaction of oxygen with the nonmetals in period 3. These are silicon, phosphorus and sulfur. Each of them react with oxygen to form their corresponding oxides, but chlorine and argon do not react with oxygen. So silicon plus oxygen is silicon 4 oxide. Phosphorus burns in air with a white flame, forming a mixture of phosphorus 5 oxide and phosphorus 3 oxide. So phosphorus forms 2 oxides when it burns in oxygen, which are phosphorus 5 oxide and phosphorus 3 oxides. The oxides dissolve in water, forming acidic solutions. So the equations for the reactions are as below. Phosphorus plus oxygen to phosphorus 5 oxide, then phosphorus plus oxygen to get phosphorus 3 oxide. Sulfur burns in oxygen with a blue flame, forming sulfur 4 oxide. Sulfur plus oxygen to form sulfur 4 oxide according to the equation shown in the below, according to the equation shown below. Reaction with water. Sodium and magnesium reactions with water was learned in chemical families. Refer there, that is a previous topic. Aluminium does not react with cold water or steam due to the presence of a coating of aluminium oxide, which prevents any further reaction. Now, we move on to nonmetals, and we say nonmetals do not react with water. Therefore, silicon, phosphorus, and sulfur do not react with water. But chlorine reacts with water to form chlorine water. Chlorine water is a mixture of hydrochloric acid, which is HCl, and chloric 1 acid, which is HOCl. So chlorine plus water is HCl plus HOCl, which is a mixture of 2 acids, hydrochloric acid and chloric 1 acid. Reaction with acids. Magnesium reacts with both dilute hydrochloric acid and sulfuric acid, should be sulfuric 6 acid, forming a salt and hydrogen gas. Aluminium does not react with dilute acids due to the presence of an oxide coating. That one we have talked about in so many cases, where aluminium is being having that coating of aluminium oxide prevents it from reacting with other substances like oxygen, like steam, like water, and so on. However, on removing the coating from the magnesium, from the aluminium, it reacts with acids as follows. Aluminium plus sulfuric 6 acid to get aluminium sulfate plus hydrogen. Then aluminium plus hydrochloric acid, you get aluminium chloride plus hydrogen gas. The reaction between sodium and acids is explosive and should never be tried. So, note that sodium should never be reacted with acids, and the reason is because the reaction is very explosive and therefore should never be tried at all. Silicon, phosphorus and sulfur do not react with dilute acids. Now we have a table here, trends in structure and bonding of compounds of period 3 elements, and also trends in properties of oxides of elements in period 3. Now, the oxides are sodium oxide, magnesium oxide, aluminium oxide, silicon oxide, silicon 4 oxide that is, phosphorus 3 and phosphorus 5 oxides, sulfur 4 oxide. Now the structures. From sodium oxide to aluminium oxide, we have giant ionic structures. Silicon 4 oxide has a giant atomic structure, while phosphorus 3, phosphorus 5 oxides and sulfur 4 oxides have simple molecular structures. Now, the type of bonding between sodium oxide and aluminium oxide, the type of bonding is the ionic bonding. Silicon 4 oxide has a covalent bonding, while phosphorus 3, phosphorus 5, and sulfur 4 oxides have weak van der Waals forces of attraction between their molecules. The melting points. Sodium oxide has a melting point of 1280. Magnesium oxide has a melting point of 2900. Aluminium oxide has a melting point of 2040. Silicon 4 oxide has a melting point of 1610. Phosphorus 3 and phosphorus 5 oxide have a melting point of 24580, while sulfur 4 oxide has a melting point of -17. Now, the nature of the oxides. Sodium oxide, magnesium oxide, and aluminium oxide are basic. Sodium oxide and magnesium oxide are basic. Aluminium oxide is amphoteric. It reacts with both acids and bases. Silicon 4 oxide, phosphorus 3 oxide, phosphorus 5 oxide, and sulfur 4 oxides are all acidic oxides. Finally, their reaction with water. Sodium oxide forms an alkaline solution of pH 12 to 14. Magnesium oxide reacts with water to form a weakly alkaline solution of pH 9 to 10. Aluminium oxide reacts with water to form an insoluble oxide, has a pH of 7, and also silicon 4 oxide. Aluminium oxide and silicon 4 oxide are insoluble in water, and the pH remains 7. Phosphorus 3 and phosphorus 5 and sulfur, they also form acidic oxide solutions with pH of 1 or 2. Now, bonding and trends in melting point of the oxides. Oxides of sodium, magnesium, and aluminium form giant ionic structures, as we have said earlier, with strong ionic bonding. Therefore, they require large amounts of energy to break the ionic bonding. Hence, they have high boiling and melting points. Silicon 4 oxide form giant covalent structure. In a covalent structure, large amounts of energy are needed to overcome the strong bonding. Hence, silicon 4 oxide has a high melting point. Now, oxides of phosphorus and sulfur form simple molecular structures with molecules held together by weak van der Waals forces. Small amounts of energy are required to overcome the weak van der Waals forces of attraction. Small amounts of energy are required, as I have said, to break the van der Waals forces of attraction between the molecules, and thus they have a low melting point. Now, let's move on to nature of oxides across period 3. The nature of the oxides, whether they are basic or acidic oxides. Now, sodium oxide and magnesium oxides are basic oxides. They are followed by aluminium oxide, which is an amphoteric oxide, which means that it reacts with both acids and bases. Silicon 4 oxide, phosphorus 3 oxide, and sulfur 4 oxide are acidic, and they react with alkalis. Let's look at solubility in water of these oxides. Sodium oxide and magnesium oxide dissolve in water, but they form alkaline solutions. Sodium oxide is very soluble, while magnesium oxide is lightly soluble in water. Aluminium oxide does not dissolve in water. Oxides of nonmetals dissolve in water to form acidic solutions. However, Silicon 4 oxide does not dissolve in water. So note that silicon 4 oxide does not dissolve in water. Now reaction with acids. Reaction of the oxides with acids. Sodium oxide and magnesium oxide, being basic, react with acids to form a salt and water. Aluminium oxide reacts with acids and alkalis, therefore it is an amphoteric oxide, as we had said before. Now, oxides of nonmetals do not react with acids, but react with alkalis. Alkalis are soluble bases. So instead of reacting with acids, they react with alkalis. Now let's move on to trends of properties of chlorides of elements in period 3. Let's look at their chlorides and how they behave in different reactions. Sodium chloride and magnesium chloride have giant ionic structures, and therefore they dissolve in water to form neutral solutions. That is sodium chloride and magnesium chloride. Neutral solutions. Aluminium chloride has simple molecular structure and it dissolves in water and it's fairly soluble in organic solvents. Aluminium chloride undergoes hydrolysis in water to form an acidic solution. Now note something about these ions with a high charge density of +3. Salts of ions with charge density of +3 and above, an example is aluminium 3+ and iron 3 ions, undergo hydrolysis in water to form acidic solutions. So that is something to note, that the salts with an charge density of +3 and above usually undergo hydrolysis in water to form acidic solutions. Phosphorus 3, phosphorus 5, and silicon 4 chloride dissolve in water, forming acidic solutions. So those are examples of ions with a charge density of +3 and above. Now, trends in bond types and melting points and boiling points of period 3 chlorides. Sodium chloride and magnesium chloride have giant ionic structure with strong ionic bonds, hence have a high melting and boiling points. Sodium chloride has a higher boiling point than magnesium chloride. The reason for this is because sodium has a large atomic radius and therefore it's more electropositive than magnesium, hence forms stronger ionic bonds than magnesium. Aluminium chloride forms a dimer molecule whereby molecules are held together by weak van der Waals forces, hence it is easily broken and has a low melting and boiling point. Silicon 4 chloride, phosphorus chloride, and sulfur 4 chloride have simple molecular structures with weak van der Waals forces holding the molecules together, hence have low melting and boiling points. Now that marks the end of our lesson. Hope you've been attentive enough and you have been able to understand every point. Let us meet again in the next lesson. Cheers.
Our education, baby. Come on.